Hello, welcome to this video. My name is Mr. Long and I'm your math teacher today. I'll be going through 8 questions from the 2020 to 2022 PSLE examination questions from the Foundation Mathematics booklet. Alright, and let's get started. In today's video, I will be focused on fractions questions. This is the first question taken from the 2021 PSLE exam question, paper 1, booklet A, question 6. Now, I hope that by the end of today's video, you will see that so many of these questions that appear in PSLE also appear in your daily work from your workbook, your textbook, and your worksheet. Alright? And I hope that gives you the confidence and the encouragement to do your daily work well. This first question says, what fraction of the stars are shaded? So what fraction of the stars are shaded? Now how will you use this video? Please pause and try the questions on your own first on a piece of paper or on an exercise book. After trying for maybe 1 to 2 minutes, then you may press the play button again to carry on to listen to the explanation. Okay, so let's find out how many stars are there altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9 stars altogether. So there are a total of 9 stars. So how many are shaded? 1, 2, 3, 4. So 4 out of 9 stars are shaded. So the answer for question 14 is 1. 4 out of 9. Let's go to the next question now. Again, a reminder to pause the video to try the question. Okay, have you tried it? Now this question appears in the 2021 paper 1 booklet A. And the question is, which fraction is the greatest? And there are 4 fractions given here. Now this question tests you on your knowledge on making equivalent fractions. Equivalent fraction means can you make them into a form where you can compare them more easily. They also test you on your ability to compare the fractions based on certain characteristics. For example, 9/10 and 9/11. Notice that the numerator are the same. If the numerator are the same, then it's very easy to tell which is the larger fraction. And this will be the larger fraction. This, if you compare these two, I will cross this out because this is the larger fraction. Now how do I know? Let's give a simpler example of, let's say, again remember we talk about numerator being the same. So in this case, it's 1/2 and 1/3. Both of these fractions have the numerator of 1. But how can I tell that this is the larger fraction? So let's take away 1 whole and the same size of 1 whole here. This 1 whole is cut into 2 equal parts. This 1 whole is cut into 3 equal parts. One of these 2 parts is this size. This is half. Whereas one of this is a much smaller piece. Do you see that? Therefore, I can say that half is larger than 1/3. Likewise, for this, if the numerator is the same, then the one with the smaller denominator will tell you this is the larger fraction compared to this. Okay, now let's compare these two. Numerator is not the same. Denominator is also not the same. But I can change this to be a fraction with the same denominator as the fraction below. How can I change this? This will be 2 times 3 is 6. 1 times 3 is 3. Now what does this mean? Well, remember we have a half here just now. How can I change this half, alright, like this half, to a 3/6? So let's try, just to understand this in case you have forgotten. Here's 1 whole, and I cut into half, means 2 pieces here, and this is my half. How can it look like 3/6? Well, now it means that instead of cutting this one whole into two parts, we can also cut it into 6 parts. You can see this one whole. There are now 1, 2, 3, 4, 5, 6 parts. Of the 6 parts, 3 of them are shaded. 1, 2, 3. So I can say that 3/6 is the same as half. You see, half is this part here. 3/6 is also this part. They are the same. And comparing this 3/6 to 5/6, then now this is a very easy comparison. You can see now these are all cut to the same size. Out of this whole one whole, 5 of these are shaded. So of course this is the larger fraction. So okay, between these two, we know this is larger. Let's cross it out. Now I'm left with these two to compare. So let's do a recap. We have done a simple comparison here, and we cross this one out because this is a larger fraction than this. We have compared these two, and we're able to cross this one out because this is a larger fraction than that. Now we're left with just option 2 and option 3, these two. How can we tell which is the larger fraction? I will suggest that you change the denominator to be the same because that makes the comparison easy. For example, the denominator here is 10 and this is 6. They're both not the same, right? I'm going to just rewrite them here. So let's change them to be the same. Very simple, to be the same denominator. I just multiply this by 10, I get 60. I multiply this by 6 and I get 60. Right, 10 times 6, I get 60. 6 times 10, I get 60. Now the numerator should also be changed. 6 times 10, 5 times 10, I have 50. 10 times 6, 9 times 6, I have 54. Now if the denominator is the same, then the size of the numerator will tell me which is the larger fraction. Now that with the same denominator here, clearly this is the larger fraction. So the answer for this is 9/10. 9/10 is the greatest fraction in this question. Third question, which fraction is in its simplest form? Okay, I have 2/4, 3/5, 4/8, and 5/10. Now, simplest form means I cannot divide the numerator and denominator anymore to get a smaller looking fraction, right, with smaller numerator and a smaller denominator. Now, how do we know if we can simplify? We look for common factors. So for instance, if I look at 2/4, right, there are common factors here of 2. Right, if I think of 2 times table, 2 and 4 are here. So that tells me I can divide this by 2 because it's in the 2 times table. 2 divided by 2, I get 1. And this is here, right, in the 2 times table. I can divide 4 by 2. 4 divided by 2 gives me 2. So this can still be simplified. Therefore, this fraction is not in the simplest form because I can still simplify it. Now let me start from the next one from the bottom. I see 5/10. I see 5, right? Let me think of the 5 times table. Okay, now we then rewrite 5/10. Okay, if 5 is here, 10 is here, that tells me I can simplify this using the factors in the 5 times table. I divide this by 5. 5 divided by 5, I get 1. 10 divided by 5, I get 2. I can still simplify this further. So 5/10 is not the answer. Next one, let's look at 4/8. Now, which times table should I look at? Good. I look at the 4 times table. You can tell 4 is in this 4 times table and 8 is in this 4 times table. I can divide 4 by 4, I get 1. I can divide 8 by 4, I get 2. I can still get a half. So these three are not the simplest form. The answer clearly is 3/5. And how can we be very sure? Now, so I look at the 3 times table. 3, 6, okay, I don't have to write everything. 3 is in the 3 times table, but 5 is not in the 3 times table. So this tells me this cannot be divided, this cannot be simplified further. So this is already in the simplest form, and the answer is 3/5. Let's go to the fourth question now. Right, we'll be doing this question from the 2020 Paper 1 Booklet B. Just a reminder to pause the video to try it on your own for 1 to 2 minutes before you play the play button. Okay, have you done it? 5/9 minus 1/3. As always, you have to change the denominator to be the same. Alright, so I can see, these are, for example, 3 times table, right? So I can change this 1/3 to my third to 3 to a 9. So how do I do it? I multiply by 3. I multiply by 3, I get 9. 1 multiplied by 3, I get 3 9s. Here I remain unchanged, 5 9s. And then I subtract. Denominator, I don't subtract, I keep it the same. Numerator, 5 minus 3, I get 2. So this would be the answer for this question. Simple, isn't it? I hope you've gotten it all correct so far. 4 more questions to go. Find the value of 3/8 plus half. Pause the video to try it on your own for 1 to 2 minutes first. Okay, I hope you've gotten your answer. Remember, first step, we always try to change the denominator to be the same. I know I can change 2 to 8 because it is in the 2 times table, right? 8 and 2. 2, 4, 6, 8. This tells me I can multiply 2 by 4. 1, 2, 3, 4. I get 8. 1 times 4, I get 4. No change to this, 3/8. Then I keep the denominator the same. I don't add the denominator. This tells me it's 3 plus 4. Answer is 7/8. And that's a value of 3/8 plus half. Next one. Pause this video and try this. Okay. Now, for those in my class, we've been doing this, right? If you're doing it in 2023 now, term 1, week 4, we've been doing this revision for a couple of weeks now, right? Let's change this to a mixed number, and I'll share with you both ways of doing it. I'll try to take out as many 1 whole as I can. So that's a recap. What is 1 whole? If my 1 whole is cut into 7 parts, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. I want to see how many 7s can I take out from 18. Okay, so if I take out 7, 18 minus 7, I still have 11 left, right? So from 11, so 18 minus 7, I still have 11. I can still take out another 7, I'm left with 4. So I can still take another 7 out, I'm left with 4. Let's double check. 7 plus 7 is 14. 14 plus 4 is 18. Okay, denominator no change. This tells me I have 1 whole, 2 whole, and 4 7. So this is one way of doing it. Another way of doing it is this. 7 times 2, I get 14. 18 minus 14, I have 4. So the answer is 2 whole, remainder of 4 7s. Right, that's how you can get the answer as well. Let's go to the next question. In the previous question, we tried to change in an improper fraction to a mixed number. In this question, we're doing the reverse. We're changing a mixed number into an improper fraction. So pause the video, try it before you play the video. Okay, so now I know this is 2 whole and 1/4. Now again, I'll do both ways to show you. I know in this fraction, alright, 1 whole will mean I have all 4 parts here. So let me think, how many 1 whole can I make from this? how can I change one whole into a fraction? There are two whole here, right? 2 means 1 plus 1 plus 1 quarter, right? This is my 2 whole, this is my 1 quarter. I just leave the fraction alone. So 1 whole would mean 4 fourths, right? 4, or you say 4 out of 4, then plus this. Let's double check. This is 1 whole, this is 1 whole, 2 whole is here. So far what I've done is to change them all into fraction, change this into a fraction, then no change to the denominator. 4 plus 4 is 8, 8 plus 1 is 9. So this is one way of getting the answer. The other way, and of course children, either way is fine, it's up to you, whichever you think you understand better. Okay, your teacher would have taught you 2 times 4, then the answer plus 1, right? So 2 times 4 is 8, 8 plus 1 is 9. And that's the other way of getting to your answer. Now we will move on to some problem sums. In the previous 6 questions, we had some revision on how to do the very simple mechanics of fractions, adding fractions, simplifying fractions, changing fractions from improper to proper, and so on and so forth. Now we go on to those 2-mark questions like this. This is from the 2020 paper. Alright, paper 2, question 10 is a 2-mark question. Now you will pause this video, try it for 3 to 4 minutes before you play it again. I hope you have done it. Now let's learn how to do this. Now Adam bought a block of butter. He used 3/5 of it and cut the remaining butter into 6 equal pieces. What fraction of the block of the butter was each piece? So I'm going to redraw the model here. So this model represents my block of butter. Alright, he used 3/5, so I'll cut into 5 parts because the denominator tells me how many parts to cut into. Alright, 3/5. So this is the part that he used. 1/5, 2/5, 3/5. And this part is what we call the remaining. This part that I didn't shade is the remaining. Okay, remaining. And the question says that Adam, what did he do? He cut the remaining butter, this part, into 6 equal pieces. Very easy to cut into 6, right? So every part here I cut into 3. So the question basically asks us, what fraction of the block was each piece? Asking us, how do I describe this one piece in terms of a fraction of the whole piece? Now I'll show both ways of doing it, and of course one of the ways is faster and easier, but it's up to you, okay, whichever you prefer. Just now remember I cut 1/5 into 3. I can cut every 1/5 into 3. That will give me 15 pieces. You see, there were 5 at first. I cut each part into 3. I have 15 altogether. And this is 1 out of 15. And that is the answer. Now first, this is through model drawing to get the answer. Another way of doing it is by not drawing model. Remember, he had 3/5. He had 1 whole at first, and then he used 3/5. So there are 2/5 of the butter left. Of this 2/5, we know that he cut the remaining into 6 equal pieces. We talk about in equal means that he divided it into 6 equal pieces. Remember the earlier model like this? These 2 were the remaining, which he cut into 6. So the idea of cutting into 6 pieces means he divided this into 6 pieces. So this is now what we have been practicing for the past couple of weeks. So how do we divide the fraction? The first one, we don't change this. fraction. The next thing here we see this operation of divide. We will change this from divide into multiply. And then for this 6 whole, okay, my students in class will be taught to do this. And then they're supposed to flip this to 1 6. Then now they will simplify this. Now there are two ways you can do this. Some of them will do it this way. 2 times 1 is 2. 5 times 6 is 30. Then they'll simplify this. Okay, 30 in the 2 times table. I divide this by 2, I get 1. I divide 30 by 2, I get 15. I have 115, which is exactly the same answer as before. Alright, like just now that we did it. And I can't find it now. Somewhere on my model. Here. Okay, 115. Now, again, for my students who are not good at doing this, when they see 2 divided by 30, they can actually do this. 2 times 1, 2. 3 minus 2 is 1. Bring this 0 down. 2 times 5, I get 10. I subtract, I get 0. Alright, this tells you when you divide this, you get 15. You divide by 2, you get 1. So, and they get this answer. And that's how they can change this to this answer. Another way is for those who are better at simplifying. Once they get to this, they will compare this numerator and this denominator. Can I simplify this? Yes. See my times table. 2, 4, 6, 8, right? 2 is in the 2 times table. 6 is in the 2 times table. This tells me I can divide 2 by 2 and I get 1. I can divide 6 by 2 and I get 1, 2, 3. I get 3. 1 times 1 is 1. 5 times 3 is 15. So if you are better at getting to your answer using this way, then you simplify first before you multiply the numerator and the denominator. If you're not so good at doing this, then you just multiply the numerator by numerator, denominator by the denominator, and then you further simplify when you get to this fraction. Now we will do the last problem sum. Okay, please pause this video and try this. This is the last question, so I hope you'll give it your best like you've been doing for the previous question. Okay, let's start. Now John had some money. He spent 2/3 of it, it meaning his money. He spent 2/3 of his money on food. 1/5 of his money, it means money. He spent 1/5 of his money on books. What fraction of the money did John spend on food and books all together? I love it when I see all together because most likely this tells me I should add them. He spent 2/3 on food, 1/5 on books. So all together, well, you just add these two. Imagine this is not a fraction. Imagine this is, let's say he spent $10 on food. Imagine this is not a fraction. He spent, let's say, $2 on books. So how much he spent on food and books altogether? I'll just add them. Same thing when they are in fraction. When I want to add fractions, I will need to change the denominator to be the same. 3 and 5, I can think of it as, okay, I can multiply these two. I get 15. 3 times 5 is 15. 2 times 5 gives me 10. Then here I have my 5 times 3 is 15. 1 times 3 gives me 3. When I add these two together, my answer is 13, 15. Right, and that is my answer for part A. So what fraction of his money did John spend on food and books altogether? He spent this fraction. Next part, again, pause the video to try the question first. Okay, now always remember the label. This was the answer for question A. Now this one is for question B. So how much did he spend on books? Now we know from the earlier question in part A, 2/3 was spent on food, 1/5 was on books. Now in this part they are telling us he spent $104 on food and books. We knew just now from the answer, he spent 13 out of 15 parts of his money on food and books. What does that mean? So that means that he spent, if one whole is this, alright, and there are 15 parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 parts. He spent this amount on food and books. Out of this amount, this was what he spent on the food. Okay, and this is what he spent on books. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This part was on food, and this part was on books. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. See? And now we know that he spent $104 on food and books. So all of this is $104. So I can see that 13 units here, because I can count 13. Alright, or I can see from the fraction it is 13. This is equivalent to $104. So what is 1 unit? Well, I can divide this by 13 and I get the answer $8. I can use a calculator for this, because this is in paper 2, or I can just do this. 104. Of course, this will mean that you need to know your times table. I multiply by 8, so I can show you what 13 times 8, 3 times 8, 24, 1 times 8, 8 plus 2, 10. Okay, so 1 unit is 8, that means it is 8, 8, 8, 8, and so on. So the question says, how much did he spend on books? Well, he spent 3/15 of it on books, so I need to know 3 parts. If one part is $8, then 3 parts or 3 units will be 3 times 8 will be $24 on books. And now this video concludes this final solution concludes our lesson. And anytime you wish to revise fraction, please come back to this video again. Watch through the first 6 questions that revises the basics of it, and then try those questions. It's okay to try the same questions over again and over again. I wish you all the best. Take care. Goodbye.